In this section, we'll define malware categories and characteristics and talk through protective countermeasures to keep networks, systems, and data safe from compromise. It's important to understand that malicious software exists in many forms. It spreads through many different methods, and it's created to achieve many different types of results. There really isn't a single box or set of boxes that, for that matter, that we can cleanly place all of malware into when classifying it, but there's a few key classification methods that can be useful in categorizing what's out there. One way of classifying malware is by categorizing it in terms of how it propagates. For instance, viruses typically propagate themselves by prepending and postpending themselves to executables on a system where they reside. Now, they can spread through email, social media, or file sharing. Worms are another classification of malware characterized by self-replication of standalone executable code, many times by way of remote exploits which allow them to self-propagate somewhat exponentially. Trojans are another classification of malware that are disguised through social engineering mechanisms. And they're disguised as useful, desirable, and legitimate software. Malware can also be classified by the concealment methods that they use. Malware writers are always trying to outwit the antivirus software authors, and this involves the continuous manipulation of how the malware conceals itself from the scanners. An encrypted virus, for instance, is a type of virus where a component of the virus generates a random encryption key, and it encrypts the rest of the virus and stores the key with that virus. When an infected program is instantiated, the virus uses the key to decrypt itself, and when the virus replicates, it generates a new and different random key in the next iteration or mutation of the virus. Now, since most of the virus is encrypted with a different key, for instance, there's really no consistent bit pattern for an antivirus scanner to observe. A stealth virus is a virus type that is especially designed to conceal itself from detection from antivirus software. Here, the entire virus is hidden as opposed to just the payload of the virus. It can use techniques such as code mutation, compression. It can use rootkit techniques as well to achieve the desired results. Another class of malware is polymorphic viruses. Now, polymorphic viruses mutate with every single infection, making the detection through a signature-based means very difficult. A metamorphic virus rewrites itself completely at each iteration, which makes it almost impossible to detect. Metamorphic viruses may change their behavior and their appearance, making it more difficult for malware scanning tools to detect them. A third classification mechanism is by payload. Malware payloads essentially reference the outcomes or intended effects of malware. For instance, if malware is classified as ransomware, then that essentially describes what the malware does. Ransomware, for instance, will encrypt a user's data and require them to pay to decrypt and recover that information. Ransomware has become much more popular in recent years. You also have keyloggers, and keyloggers are a type of malware that silently will capture a user's keystrokes with the intent to lift sensitive information such as username and passwords and credit card numbers. Some malware payloads will corrupt operating system files. Others will install backdoors with listeners that will connect back to a central command and control infrastructure, such as botnets, effectively turning machines into zombies that are used for distributed denial-of-service attacks. Adware is another payload type that will display unwanted advertisements and falsely boost click rates in order to charge more for advertisement. Malware can also be classified by the targets that they impact. Target classifications include boot sector viruses, file infectors, and macroviruses. Macroviruses are platform independent and specific to a given type of file. A popular example is a Word or Excel macrovirus. These document types can be opened on different machines and different operating systems, and an infected document will have the malicious macros that can infect a user's system. File infectors are typically viruses that prepend and or postpend malicious code fragments into executable files that exist on a computer. Now, when it comes to malware creation, initially, in order for someone to create their own malware, they needed a fair amount of skill and programming experience. Now, there are openly available toolkits for creating viruses and other malicious software. So these toolkits are sometimes referred to as crimeware. For instance, the Zeus crimeware toolkit that's been around now for some time, and it's well established in the underground economy as being an easy to use and powerful tool for stealing personal data from remote systems. The Zeus toolkit has since become widely available for both sale and free on underground forums. The Zeus crimeware toolkit was really created for individuals to create and tailor their own Trojan botnets to attack networks. Now, the perpetrators of malware in a modern sense aren't just rogue criminals or just petty thieves, but they tend to be nation-state actors and cyber warfare organizations, hacktivist groups, and international crime rings. Groups such as Anonymous and others have captured many headlines as of late. Some of these groups are just out to promote a cause or their opinions, while others, such as nation-state actors, are out to commit corporate espionage by stealing proprietary company information. Rootkits are a special class of malware. This is a class of malware that can assume root or admin privileges on a system and thus completely conceal its activities by subverting a system's processes and file monitoring methods to hide its activity. Now, rootkits are typically categorized with several classifications. These include persistent rootkits, memory-based, user mode rootkits, kernel mode rootkits, and virtual machine-based rootkits. So we've talked about various types of malware and how we classify them. Now we're going to talk through the different countermeasures that we can implement either on a tool-based basis or from a training standpoint and due diligence standpoint to counteract various types of malware. So malware countermeasures continue to evolve as attackers continue to try and outwit those that wish to detect and stop them. Now, we can classify these typically as either host-based or network-based countermeasures. The host-based countermeasures represent our traditional antivirus software, and this has typically been the first line of defense in protecting systems from various types of malware. These systems are classified in 4 iterations, as described typically as being generations 1 through generations 4. So first generation antivirus scanners kept records of file length, and they watched for things like file length changes. This was the original signature-based antivirus model. Second gen antivirus tools focused on heuristics rules and implemented file protection using hashing instead of checksums. Now, hashing is more effective in that if a malware modifies itself to be the same size via, let's say, compression, post-infection, then a hash can still catch that type of modification. Third generation antivirus scanners used memory resident scanners that found malware by activity rather than a signature. What's interesting here is that this allows them to potentially capture things like zero-day exploits or activity that hasn't previously been documented in the wild. And then finally, fourth generation antivirus leverages scanning capabilities, activity traps, as well as advanced access control capabilities. And sometimes these capabilities are described as a combination of host intrusion prevention and host antivirus scanning. Now, while implementing countermeasures at the host is important and it's necessary, it's also important to make sure that these viruses don't get into our networks to begin with. Now, sometimes that's possible through countermeasures in the perimeter. Sometimes it's not, based upon the fact that corporate laptops, etc., might leave the trusted network and be on untrusted networks, and that information and the viruses and worms can be propagated. But that doesn't mean that we don't want to protect the perimeter, and it's an important part of defense in depth as it relates to malware. So when we talk about perimeter countermeasures, we're fundamentally talking about things such as network intrusion detection, network intrusion prevention, and then to some extent host intrusion detection, host intrusion prevention. But mostly we're focusing on NIDS and NIPS. So while these host-based measures are great, making sure that we can prevent and detect controls or outbreaks can involve not only NIDs and NIPs, but it can include things such as WAFs, or web application firewalls. So we're going to talk through some of the different methods that these perimeter countermeasures use to detect and block malicious payloads and exploits. The first step would be for and to monitor worm communication flow signatures. And this approach, of course, is vulnerable to polymorphic worms. So it's similar in the antivirus approach in that signatures are important, but they're not necessarily a be-all, end-all control because of polymorphism. A second approach in perimeter-based countermeasures is to filter based on worm containment, or to contain worms looking for worm code in various communication flows. A third control method is payload classification based on different exploit code. And then you have threshold random walks, rate limiting, and things like rate halting. And what rate halting does is it blocks outgoing traffic when it exceeds a certain threshold. Now, as you can see, there are many different points of security inspection, either at the network level or at the host level across an enterprise. Now, sometimes activity at any one of these given endpoints or network segments might not be that interesting or useful on their own, but when correlated across multiple sources, it might reveal more sophisticated attacks, such as those posed by APTs. And APTs are advanced persistent threats. APTs are many times drip-based attacks that span targets in a wide range of time in order to conceal their activity. And many times these are complex actors such as nation-state cyber warfare organizations or organized crime groups that are the perpetrators. These correlation engines are used to correlate things like security log information and other data across multiple devices such as firewalls, such as host intrusion detection, host intrusion prevention, network intrusion detection, network intrusion prevention, web application firewalls, regular firewalls, and system logs. So once we combine all that information, sometimes we can detect threats that we may not have been able to detect by looking at those logs individually. Additionally, when we take the correlation approach a bit further, this correlated data and the underlying patterns identified can be compared with and analyzed against a common set of databases that, for instance, multiple government entities and corporations might leverage in order to identify attacks such as APTs. Now, this is an emerging field, and there are many vendors emerging in this space that are offering unique capabilities to help detect and prevent against advanced and sophisticated cyber threats. So in summary, malware exists in many forms. It spreads through many different methods, and it's created to achieve many different results. Malware can be classified by propagation, by payload, and by concealment techniques. The countermeasures can include modern host-based and network-based scanning technologies, as well as by leveraging security correlation engines and by applying shared threat intelligence to identify and stop sophisticated attacks.